Now I am continuing with the question 2, 4. Now, as I finished all the other identities, the last identity for today is root 5 minus root 2, root 5 plus root 2. Now, as I do more examples, we'll be able to solve better. So, whatever I've done in this paper solving test 2, those especially who are finding difficulties, please see that you'll take the same sum and practice and understand what's happening, and watch the video again so that you'll get the concepts clear. And still, if you can't, try to do at least 2 times, watch 2 times, and then I'll see if I can help you. But see that you all try. Now I've explained in such a simple way, although you all practice it, you all won't be able to get it. Now look at this carefully, see how I'm doing, just follow the way how I'm doing. You don't have to by heart, you just have to understand what has to be done. Now I'm just looking at this number and I'm writing, see, root A minus root B, and then root A plus root B. So what am I doing here? I'm just looking at this and I'm just replacing 5 with A, B. Why? Because I want to see which identity is going to help me. Now we know that root A minus B, root A is A minus B. We have to by heart this. Okay, so actually there is a way of if you can't by heart, how to do it. Suppose you have forgotten what to do. I'll do it over here, solve it here. See, now suppose you forgot this formula, okay? See how I'm doing now? Imagine that you have forgotten the formula and you don't know. So what you have to do, that time this identity will help you. A minus B, A plus B. What is A minus B, A plus B? A square minus B square. So what you do now, just listen to me. Imagine that you have forgotten and you don't know that the answer is this. So use this identity and you have to know where A minus B, A plus B is A square minus B square. So wherever A is there, what you will put? Root A. Wherever B is there, what you will put? What is root A the whole square? Root A the whole square is root A into root A, which is A. So A. What is root B the whole square? Root B into root B, which is B. See? Have I got this? So, if you have forgotten, this same identity will help you. You should know that this is the same as A, this is the same as B, this is the same as A, this is the same as B. So, if you can't remember this way, you have to use this identity and get this answer. Okay, and you should know how to know that it is this identity. See, the signs will be opposite, and this and this will be same, this and this. So what did I do? I used a simple identity, A minus B, A plus B, and I know that it is A square minus B square, okay? So wherever A is there, you have to replace with this full root A. Because this is becoming A now, this is becoming B now. This is becoming A now, this is becoming B now. What am I doing? I'm trying to find this answer. So with the help of this identity. Okay, so if you can't remember this, then it's better you use only this identity and solve your query. I'm repeating. Suppose you don't know that root A minus root B, root A plus root B is A minus B. Using this identity, you can get this answer. So it's better that you use this identity directly. Now let us do with this formula. See. Now, who's your A? Your A is 5, because now this is root, we are using the formula root A minus root B. So who's your A? A is 5. Who's your B? B is 2. So what's the answer? 5 minus 2. Now I want to use the identity A minus B, A plus B. A plus B, A minus B, which is A square minus B. When you are using this identity, who will be your A? A will be full root 5. this by heart this. So if you are using this, your A will be this full thing and your B will be this, okay, this full thing. Now because I have circled, it's looking right, okay. So root 5 plus root 2. Now your B will be this one. Next time I'll write the number here so that I don't have to circle it. You will get confused why this circle is. Understanding, no? So sometimes to know what's happening, look at the video. See why I did this. Okay. Now, wherever A is there, now see, you understood why I got A is root 5? Because when I'm using this identity by heart that way, my A will be the full thing. So wherever A is there, what you will put? Root 5 the whole square. Wherever B is there, what you will put? So 5 minus 2 is equal to 3. Because root 5 the whole square is root 5 into root 5. Okay? Now, this is regarding this identity, no? So, please see that you all solve this identity and then I'll give you more examples to solve. You'll get the hang of it. Okay? Now we go to the third question. Rationalize. Okay? What is 7 upon root 7? What did I say? We have to rationalize the denominator. Don't forget I'm solving the test questions. Huh? So in decimal denominator you have to do only the number. Let's do this fast. So it is 7 root 7 upon 7 cancel. See how I did so fast. That's what's happening here. I hope you all got the same answer. Now, when we say rationalize the denominator means we are rationalizing the denominator means we are taking only the denominator. So whatever is there, you have to take the replica. Now what you are putting here, you have to put here also, duplicate. Now, 7 into root 7 is 7 root 7. But root 7 into root 7 is 7. So, this 7 cancels. Now B. Four upon root 5. Okay? So what to do here? It's 4 upon root 5 into root 5 upon root 5. Okay? So we are taking only this. So it is 4 root 5 upon 5. Now if suppose there was a 10 here, example, let's take one example, okay? Suppose you got 10 root 5 upon 5. Suppose. So you can cancel. So what? Cancel and get the final answer. But here we can't cancel. I repeat. I took another example where I have said instead of 4 we have a 10. 5 so 5 to are cancel. But here nothing is cancelling, so it remains the same. Then we go to the C question, that is 1 upon root 13. What is 1 upon root 13? 1 upon root 13. So you take root 13 upon. So you are doing only the denominator. Is root 13 upon 13. It remains the. Okay. So we finish with the third question. Now we go to the fourth question. Is the following rational or irrational? The first one. Here we only have to say whether it's a rational and then we have to say it's an irrational. Now look at this. This is 3 upon 17. You have to ask one question. Is this the form P upon Q where Q is not 0? This is the first condition. What's the second condition? P and Q have to be integers. Is this satisfying this condition? Is this satisfying? P upon Q? Yes. Q not equal to 0. Is P and Q integers? Yes. 3. I can place 3 on the number line. What about 17? 17 will be somewhere here. Okay. So it will go on this number line. So this is a rational number. And it is short form. What about 9 upon 20? Is it P upon Q? Yes. Is Q not equal to 0? Yes. Are these integers? Yeah, these are positive. Is it a positive rational number? Okay. So over here, they are just asking whether it's a rational or irrational. They are not asking whether it's terminating or non terminating. Understood now? So now we go to the last question. Now it's the 5th question. Here we have to convert. Sometimes question comes like this. Convert to decimal. Or the same question can come. Find the decimal expansion and state if it is terminating or non-terminating. So only one question is given here. 2, 5 upon 12. So we have to find the decimal expansion of this. Convert to decimal, I have told you, means division. We have to do division. Okay. So here, see, point to be noted. Here they are asking you convert to decimal. Are they asking to find whether it's terminating or non-terminating? No. So since they are not asking you whether it's terminating or non-terminating, you don't have to check. You don't have to check if R is equal to 0 or R is not equal. You don't have to check. You don't have to check. You don't have to do this. Why? Because they are just saying convert to decimal. I repeat. When the question comes convert to decimal, it means they are just telling you to find the decimal point. They are not telling you to check whether it's terminating or not terminating. If they are asking to check terminating, we have to find if R is 0. And they are asking to check if it is non-terminating. So if it is terminating or non-terminating, we have to check on this condition. If remainder is 0, it is a terminating rational number. And if remainder is not 0, it is non-terminating, and we call it recurring. Recurring means it keeps on repeating. Okay, and then we put the bar on top. There is another condition which you are going to do in the next question. There are 2 conditions. If you want to check if it's terminating, say after me. Remainder, we have to check if remainder is 0. Because if remainder is 0, again, if you want to check if it is terminating, we have to check if remainder is 0. Because if remainder is equal to 0, it is terminating. And if remainder is not 0, it is non-terminating, recurring. What's another name for recurring? Repeating. So, there is another condition for terminating. 2, say after me, 2 raised to m into 5 raised to m. So, this is the form of, say after me, denominator. So, the form of the denominator means the denominator has to take this form. The minute the denominator takes this form means yes, it is terminating. Now, when are we to do this? When they say without decimal expansion state, if it's that time we don't have to see. When they say without decimal, without division or without actual division, that time we don't have to divide. We can use this condition. So there are 2 conditions. When they say find decimal expansion, check if it's terminating or not, that time we do division and we check if remainder is 0 or not. But if they say without actual division, this is the second condition which comes from. Is that clear? So if it comes without actual division, that time we have to check the denominator. So there is one question which we have to do. So we'll do it later. 2 into 12 plus 5 upon 12. 2 into 12 is 24. 24 plus 5 is 29. 29 upon 12. So how to convert this? Is a mixed fraction. This is a improper fraction. Why? Let's revise our fraction. When the numerator is greater than denominator. It's called improper. But it's a rational number, yes. P upon Q. Q not, you are not saying the P should be less or the P should be greater. It should be of the form. So, in other words, fractions can be rational numbers. We'll be discussing that. Fractions can become rational numbers, but all rational numbers cannot become fractions. That point we will discuss later. Okay? Now, how to do this? Do this thing. Let's do 12 3s will go? No. 12 2s, yeah. Now, what to do? This 5 is smallest, we borrow. So don't forget, we have to put a point when we borrow, no? So 12 3s are 12 4s are 12 5s are 12 5s are 60. So 12 4s are 48. Okay. Now what to do? Let me say 2 0. 12 1s are 12. 12 2s are 24. So 12 1s are. You have to go on till you get the same this back. So basically remainder is not 0. So it looks like it will keep on. Okay, so we have to check if remainder is not 0 means it is not terminating, and non-terminating is also recurring. So we have to see when it starts repeating. So we have to keep on going till we reach the same value again. I'll show you that way. Now let's do 12 6 are 12 7s are 12 6 are what? 72. Hmm? 72, no? Yeah. We'll check out. We did the division correct. 12 2s are 24, 12 3s are 36 now. 5. 12 4s are 48. Let's see if we did it correct. 12 1s are 12. Okay. Now 12 6s are 12 7s are. What will happen here? 6. Again, what will happen? So it looks like that it is recurring on this. So it will keep on. So they're trying to find a decimal. So you only write this. They are not asking you to find up to where it is recurring. So you just write the decimal is 2.4. Take up to 3 digits. Okay. I hope you all got this answer. Okay, next, last sum. First, I have to make till 30 minutes. If it crosses 30 minutes, the video becomes too long and then it doesn't get uploaded soon. It takes very long time to upload. So let's do the last sum. The last sum is, where it is gone? 3. Okay. It is the 6th sum. I'm just writing randomly the question. The main question is on the test. We have to check whether it is. I'm just writing half question. I told you all the question is in the test. So I'm just solving. I don't want to write the full question. Terminating or non-terminating. Now, which is the first question? The first question is 7 upon 8. No. Yes. 6 upon 4. See. Now here they are not asking to find the decimal expansion and then state if it's terminating or non-terminating. They are just saying state whether it's terminating. So they have not mentioned over here, but in my question I have specifically mentioned using 2 raised to m into 5 raised to m. Now let me repeat something. See, if they say no, find the decimal expansion, state if it's terminating. It means you have to divide it. That time you don't have to use it. But sometimes they say state if it is terminating, not terminating. They have not told you whether to do divide or you can use anything. You can use any method because both the methods are applicable to check. But if they say find decimal expansion and check, it means you have to divide. Is that clear? And if they say check whether it's terminating or not terminating using this, you have to use this method. You cannot do you cannot do division. So, and if they don't mention anything, you can use any one method. Okay, and this mostly comes from 1 mark. And one more thing, if it comes as filling the blank, as I told you, you either have to do division, or you have to use this method, correct? No? So if it comes for fill in the blanks, you don't have to waste your time to do division. It's better to use this method. 2 raised to m into 1 mark question it is. Okay. Now what we have to do here? What is the denominator? Denominator is 4. So we have to do prime factorization. I told you all. Now this is a small number, so I am purposely doing for you all to know that unless you all do prime factorization, and especially for big numbers, you all won't know. So denominator is 4. So you have to express this 4 in the form of 2 raised to a into 5 raised to a. Now you have to make this 4. So what to do? Take this 4 and see who are the factors. 2. So 4 is equal to 2 raised to 2. But now we need to check whether it is 2 raised to m into 5 raised to n. But there is no 5. So it's understood that 5 can be written as 5 raised to 0. Understood? Because 5 raised to 0 is 1. I repeat. There is only 2 raised to 2 and there is no 5. So if it's missing, it means that you can express it in raised to 0. Because anything raised to 0 is 1. If 2 was missing, then put 2 raised to 0. Yes, it is of the form. 2 raised to m into 5 raised to n. Hence it is terminating. This is the way you have to do. So see that whoever has done it wrong, please rectify your mistakes and see that you all do it all over again. Look at one time how I have done, understand, and then do it without looking, and then again check whether you have done it correctly, and then send it to me so that I know that you all have done it. Is that clear? Okay, now we go to the last question for today. Is 7 upon 8. Let's do this fast. Now we need to check of the form. So let's write this here to keep a check on it. So we need to know, okay, I have to check this. Okay. So now what to do? We write the denominator like this, 8. Then what to do? Then we do our prime factorization.